In this video, we're going to talk about Unix and Linux file permissions. And I have a written article if you prefer written format, but I'm just going to go ahead and get into it. And we split the video into several parts, so feel free to skip to the part that you need. But basically, I'm just going to jump into it. And so file permissions are split into three different things. There's read access, write access, and execute access. And then there's also, we're also splitting the file system permissions into three different types of people. And there's users, groups, and others. So the user is anybody or who's the file owner. So if you take a look here, I've got a test directory with three files: cat.txt, dog.php, and nested folder. And so cat.txt is owned by Bunny, and so is dog.php, but nested folder is owned by my user here. And so that is the user. And so we have separate file access for the user. And then there's also groups, and group access will be given to anybody who is a member of the group. So each file has a group, and in this case, all of the groups or all of the files are owned by the group Bunny. And so anybody inside the group Bunny will have the group permissions available. And then others is everybody else. So it's the guest accounts, everybody else. And so everybody else has their own set of permissions. And so the way that you can see what permissions are available is by running this ls-l command. And it will show you what the permissions are. So if you see cat.txt, all of them are hyphened. That means there's no permissions for anybody on the cat.txt file. The dog.php file, you'll notice, has rwx for the first three, which means the user has, so the first three are split for the user, or set for the user. So user has read, write, and execute access on dog.php. The second three have a hyphen, a W, and an X, which means the group of Bunny only has write and execute access, but they're not able to read it. And then the last group of people, they only have execute access. So read is hyphenated, which means they don't have it. Write is hyphenated, and X shows up, so they only have execute access. Okay, so now that we know how that works, all we have to do is figure out how to change the permissions. And there's two ways to do that. You can use the number format, or you can use the UGO method. And so the number method basically works like this. We have execute, write, and read, and no permissions. And so each one has a number representation. So if you want to have a certain permissions set, all you have to do is add the numbers together of the ones that you want. So if I want execute and write, all I have to do is add the execute value and the write value together. So if I want write and execute access, I add 2 plus 1, which is 3. If I want, execute, write, and read, then I add all of them together. 4, 2, and 1, which is 7. Read and write is 6, etc. So we just use those numbers to set the permissions. And the way that you would do that, let's say we want to give cat.txt some different permissions. We would use chmod, and then we would enter the numbers in order. So we start with the user, which is the first three, then the group, and then others. So the user will probably want the most power, I guess. So we could say we'll do this one: read, write, and execute, which is 7. So the user gets permission of 7. And then the group let's say the group only needs read and write access. So we'll give them read and write, which is read plus write, which is 4 plus 2 is 6. So that one gets 6. And then let's say this is like a very important file. So the the user, or the others, only get read access. And so read is 4. So we'll say 4. So 764 permissions. So chmod 764 and then cat.text. So that will change that. So let's go ahead and hit enter. Oops, and I have to do sudo because I believe it's because the file is owned by Bunny and I'm not Bunny right now. So sudo chmod. Okay, so now ls-l to see what happened. And again, now we have the different permissions. So the user gets read, write, and execute. The group of Bunny gets read and write. And then the others only get read access. An alternative way to change file permissions is with the symbols U, G, O, and A. So basically, lowercase u stands for user, G stands for group, O stands for others, and A stands for all. And basically what you do is you use these symbols to set the read, write, and access to them. And so you can set with the plus to add an access privilege, minus to remove, and equals to set. And then you use R, W, and X for read, write, and execute to set those to the users, groups, and others. So to see that in action, let's go ahead and take a look at our terminal. So I went ahead and reset the permissions. So cat.text is empty, they have no permissions, etc. So let's go ahead and set some permissions. So we'll do chmod and we'll do u, so for users, equals, and we can do read and write, or read, write, and execute, or whatever. And another thing we can do is, at this point, equals will basically do the same thing as r as plus. So u plus read and write would be add read and write to the user. So let's go ahead and just stick with that for now. We'll do cat.text. Oop, and I forgot again to do sudo. Okay, so ls-l. And now we've got read and write access on the cat.text file. So let's go ahead and do that to dog. But we'll also use equals this time, just to see that it does the same thing. And basically does. So let's see here. So we can also chain commands together. So let's do this to the nested folder now. And we'll do users equals read write. Group we'll set to execute, and others will set to read. And then, and again, so we can do plus and all sorts of stuff. And then just, okay, so yeah, that'll work for now. All right, there we go. So read write, and then execute, or read write on the users, or the user, execute on the group, and then read for others. And that's basically it. There was one other thing. Oh yeah, equals. So like, let's say we have read and write on the users. If we do equals, well, okay, so we've got cat.text. So let's do the cat.text file. We'll edit the cat.text, and we'll use the equals to set it. So let's set the user for the cat.text to only be execute. So we'll use equals to do that. So ls-l. So equals is going to overwrite everything and set it to exactly what it says with the equal sign. So that's using UGOA. And that's about it for changing the permissions. Another important part of file permissions is being able to change the file's owner and the group. So let's go ahead and take a look at how to do that. So if we take a look at our current directory, let me just clear this. We have John Curry is one of the owners. Bunny or cat.txt is owned by John Curry, and the bunny is the group. So, and then we have bunny and admin and bunny and admin. So the file owners on this side and the groups that the file belongs to on this side. So let's go ahead and see if we can change that. The way that you do that is with the change ownership command with chown. And so we can, let's change dog.php to be owned by John Curry. So chown, and then we'll say John Curry, or the username, and then I still need to do sudo. I always forget that right now. Sudo, okay, John Curry, and then the file name, so dog.php. So ls-l, and now dog.php is owned by John Curry. And let's see here. So to change the group, you would use chgrp. There's another way you can do it. I'll show you in a sec. But chgrp, again, sudo, and the group name. So let's say we want nested folder to be owned by bunny. So we'll do bunny, and then nested folder. ls-l, and now it's owned by bunny. So again, change group to the group name that you want it to be owned, and then the folder that you want to change. And that's how you do it. And then if you want to do both, you want to change both, we can do chown, and then separate them by colon. So let's say we want dog.php to be owned by bunny, and then have the owner be bunny as well. So we've got chown, owner is bunny, group bunny. And then we'll do the file, dog.php. I always forget that. Sudo ls-l. And now we've got bunny and bunny for the dog.php. So that's how you change the owner and the group. And then there's one more thing, and we can do this recursively as well. So let's go ahead and take a look at first nested folder, ls-l. Okay, so all of these are owned by bunny and cd supernest. Again, the group is bunny. So let's go ahead and change the group to admin and the owner to bunny. But we'll do it recursively. So I'm going to change chown, and we're going to do bunny is the owner, and admin is the group. Oops. So colon admin. So owner, group, and we'll do it to the test directory. And we're going to do this recursively. So after the chown, you do a capital R, a hyphen capital R. So chown, hyphen capital R, bunny, colon, admin, test. And I think I almost forgot again. Sudo. Okay, ls-l. And we've got bunny is the owner, admin. So let's go ahead and do cd into test, bunny hyphen admin, bunny and admin, and bunny and admin. So we can do this nested, or so we can do this recursively, I'm sorry. And then we can also do chmod recursively as well. So with the hyphen capital R. A quick note on security, you don't want to give anybody access to anything unless they absolutely need it. You don't want grandma accidentally coming into your Apache web server and deleting it thinking it's your email or something like that. So be very careful about who you give access to, and that's why 777 read write execute for every user is a really, really bad idea. So only give users access to stuff they need to see. I wasn't able to fit all the content into one video, so be sure to check out the other two or one or two videos that come along with this to help you fully understand file permissions, users, groups, owners, and sudo, and all that kind of stuff. So check them out, and I'll talk to you soon. Thanks for watching the video, everybody. I hope this was super helpful. Go ahead and check out my website, truthseekers.io, and check out all of the stuff that we have on there. I'm trying to build a community of programmers and technology enthusiasts. So check out what we have, see if you can solve some of our programming challenges and stuff like that. So yeah, check it out. Have a good day.